Sample problem 1.3. Ice cubes float in a glass of water because solid water is less dense than liquid water. A, calculate the density of ice given that at 0 degrees C, a cube that is 2 centimeters on each side has a mass of 7.3 grams. 7.36 grams. And B, determine the volume occupied by 23 grams of ice at 0 degrees C, right? So this is the freezing point of water is 0 degrees C at normal pressure. So ice cubes and water are in what we call an equilibrium. Liquid water and and solid water, ice cubes, are in equilibrium with each other. They're both stable. So let's take a look here at how we go about this. We want to calculate the density. The symbol for density that we'll use is a D. That's not universal. There are other symbols that are used, but we'll use D. The density of an object or of a substance is its mass, so I'll use M for mass, divided by its volume V, typically uppercase V, but not a requirement. So mass over volume. So we have the mass in part A, right? It tells us the mass is 7.36 grams. But they don't tell us the volume, right? All they do is they tell us we have an ice cube. And they tell us the dimensions of that ice cube. So there's our little ice cube. But they do tell us that the length is 2 centimeters. And since it's a cube, the length, the height, and the width, or the depth, is going to be the same. It's all 2 centimeters, right? It's a cube. So what's the volume of a cube? The volume of a cube is whatever its length is cubed. So that would be 2 centimeters, and then you cube it. So you would get 8 centimeters cubed. So when you do an operation on a measurement, this is called a measurement. A measurement has a numerical value, 2.0 for example, but it also has a unit. Typically it has a unit. So the unit is centimeters. So the operation is we're cubing this measurement. So if you cube the measurement, you cube the number, so 2.0 cubed is 8.0, but you also cube the unit. So centimeter becomes centimeter cubed. Now, to be honest with you, there's a little bit of an ambiguity here. What we're doing is we're cubing centimeters. So it's really, I'm going to put it in parentheses there just to show. It's centimeters cubed, but prefixes can kind of sometimes cause some ambiguity. So there we go. So now we have our volume. Okay, so now we can figure it out. Take a look at those two numbers, 7.36 and 8.0. Is that calculation, is that ratio going to be greater than 1 or less than 1? Without using your calculator. 7 is under 8, right? So that means you're going to get a number that's less than 1. Does that make sense? If you think about it, ice cubes float on water. The density of water is 1 gram per centimeter cubed. I'm actually going to write that here. The density of liquid water, L for liquid, is approximately 1 gram per centimeter cubed. So it makes sense, right, that your density of the ice cube would be less than 1. It floats on water, right? Ice cubes float. Solid water is less dense than liquid water. That is, by the way, unusual. Most materials, the solid is more dense than the liquid, but water is a peculiar material, and its properties are somewhat unusual. So that makes it so that one of the peculiar properties is that the solid form, ice, is less dense than the liquid form, which is water. So 7.36 divided by 8.0, and you get 0.92. And then with units, you do the same thing. You say, hey, there's grams, but we're dividing it by centimeters cubed. And there you go. So there's your density of the ice cube, 0.92 grams per centimeter cubed. Now I'm going to point out, this is something you should remember. A centimeter cubed is sometimes called a cubic centimeter. And we call that cc. So 1 cm cubed is the same as 1 cc. But it's also the same as a milliliter. So this is called milliliters. I would recommend that you memorize this. That 1 cm cubed is the same as 1 cc, which is the same as 1 ml. I recommend you memorize that, okay? Make a little note here. Memorize this. Now, let's do part B. In part B, it says determine the volume occupied by 23 grams of ice at 0 degrees C, same temperature. They're telling us that the mass is 23 grams, and they want to know what the volume is. Well, here's how we could go about that. The density is equal to the mass divided by the volume. If you multiply, I'm going to do this in 2 steps. If you multiply both sides by volume, let me do this. There we go. So I'm multiplying the left side by volume. I'm going to multiply the right side by volume. And then here's our logic in terms of algebra. Volume divided by volume is 1, right? Based on our arithmetic understanding. 2 over 2 is equal to 1. 10 over 10 is equal to 1. X over X is equal to 1. There is a limit to this. There's one exception. And that's where X is equal to 0. It doesn't work if that's the case. But we'll assume the volume is not 0. So volume over volume is 1. So now our result of that would be VD equals M. We want to find V, so what's the next step? We're going to divide both sides by D. D cancels, just like V canceled, and you now have volume equals mass over density. There you go. That's the idea now. I'm running out of room here, so let me create another room here. Now, the volume is the mass. Again, we have the mass, 23 grams. But we calculated the density in the first part. Notice in chemistry calculations, you often use the result of one part in your calculations for the next part. So that's what's going on here. So we found in part A that the density was 0.92, right? 0.92 grams per centimeter cube. Okay, so now let's do the arithmetic. 23 over 0.92. It should be more than 23, right? It's 25. Wow, it comes out really nicely. 25. Now let me show you something about the units. These units are confusing, or they can be confusing if you don't have a lot of experience with this type of arithmetic. Here's what I'm going to do. You know that if you multiply something, let's say, for example, I have 3/5, and I multiply that by 5/5. I'm not really changing it. I'm changing the actual numbers, but the ratio is still the same. This would be 15 over 25, right? So 3/5 is the same as 15/25ths, right? This is 3 is 60% of 5. 15 is 60% of 25. So they're still the same. So what I'm doing here is I'm really multiplying by 1. That's essentially the algebraic principle. So here's what I'm going to do. I'm going to multiply this ratio by centimeters cubed over grams. I'll show you why I'm doing that. It's the reciprocal of what's in the denominator here. Grams over centimeters cubed, right? So centimeter cubed over grams. So when I do that, I'm really just multiplying by 1, right? Centimeters cubed per gram over centimeter cubed per gram is just 1. But here's what happens. In the denominator, these cancel. So now everything in the denominator has turned out to be 1. So this is equal to now grams times centimeter cubed over grams over 1. Now the grams cancel and you get centimeters cubed. So all I'm doing right there is I'm going through those algebraic steps just to show you that if you try to figure out what the units are going to be here, it's just going to be centimeters cubed. So here's what I'll say, that's our answer, by the way, 25 cubic centimeters. So let me mark down here, our answer is 25 centimeters cubed. And we could also write that as 25 cc, and we could also write that as 25 ml, right? We talked about that earlier in part A. But what I'm saying here is that if you have a unit divided by itself divided by another unit, these cancel. It's essentially 1 over centimeters cubed, and that's equal to centimeters cubed. Right? The reciprocal of a half is 2. So the reciprocal of 1 over centimeters cubed is just centimeters cubed. And there you go. So there's our answer, 25 cubic centimeters, or 25 centimeters cubed, or 25 milliliters.